यहाँ मैं थोड़ी लाइट चला लेता हूँ। ये है क्या हो गया? लाइट बिना शायद इलेक्ट्रिशियन को बुलाना पड़ेगा या फिर मोबाइल की ऐप में टिकट रेस करनी पड़ेगी। कितने झमेले हो गए ऐप्स का, शायद मैंने इसको अपडेट नहीं किया होगा। परेशान हो गए ऐप से। अरे राम, अरे कोई है क्या? अरे मैं किससे किसी को फोन लगाऊं? अरे ये मेरी कमर, मैं गिर गया। हेलो, अच्छा आप मेरे दरवाजे पे खड़े हो? अरे यार मुझे आवाज़ ही नहीं आई। हाँ हाँ हाँ, अच्छा अच्छा, कितनी देर हुई आपको आए? नहीं नहीं, मैं आता हूँ, दरवाज़ा खोलता हूँ, मुझे 2 मिनट दीजिए। हाँ मैं थोड़ा ऊपर था, मैं नीचे आके दरवाज़ा खोलता हूँ। हाँ हाँ हाँ, ठीक। अब नीचे जाके दरवाज़ा खोलना पड़ेगा। अरे ओम, खड़ी स्टार्ट। Hello all. Hi, I'm Varun Sontakke, and this is my project Aigis AI Guardian and Smart Home Companion. This project is part of Indian Electronics Project Contest 2025, which is hosted by Circuit Digest and is sponsored by DigiKey. I also thank DigiKey for sponsoring the main circuit board that I have used over here is ESP-32S3 Box 3, and also thanks to Circuit Digest for selecting my idea for this. So I will, as you have seen in the starting of the video, that in a home there is when you are using some electronics bulbs or fans which are able to control with mobile phone, they face a lot of issues if Wi-Fi is not working, if some switch were get faulty or the app is get faulty or new update you have not done. So this dependency will have some issues on controlling the light and all. Also, there is one more problem you have seen, that if your grandparents are alone at home, if they have fallen or if they have some health issues, if their blood pressure rate is high or something is happened, you will not get notified, and there is a hard for them as well to just sit up and just call you or do something. And also there is also a situation when they are home alone, how they can just go away and open the door and all those things they can do. So this solution is my project for this problems. The solution is my project. Mainly, this is a prototype right now, but we can scale it up as well. So here I'm having a robot, and this robot will be a biped robot, which is inspired by Auto DIY open source designs, and it is having ESP32S3 box 3, and also have a LCD display to show expression and all. So also to make it more entertaining, and also for kids, it's also helpful for kids to tell a story, to dance with them and all. So its functionality is mainly it is going to walk, it is going to dance, it's going to tell a story, and it's also going to control the other nodes. What are the other nodes? Let's see. First is the smart home node. In this node, we are trying to solve whenever we like voice activate something, okay, like turn on the light, turn on the fan, like this. So this master robot will take the command of voice, and it will communicate with the node, smart home node, and it will send the data over ESP-NOW, and it will able to activate the light bulb or something. It also have manual switches, which is not manual switches, it's like a touch switches over here, which is manually operated, sorry. And this touch switches are not like some mechanical component in it or something, just aluminum foil which is connected with ESP32 module. So with this, it also follow XOR or staircase logic. Whenever, for example, I have pressed the button or touch the button, it will light on the thing, and at the same time I also do the command for lighting on, it will still do the light on. If either way I give a switch off condition, it will get switch off. So there is no conflict of on state or something. Conflict will not be there with the both manual side and the command side. Also for health node, we are having one more health node, which is a health band for your grandparents. It will monitor if they have fallen, if their health heart rate is up or down, it will monitor, and it will also generate an alert over SMS. And also it will notify to robot, and robot will blow up the siren at your home and alert other as well. Also, I'm having a door node which will help you to, which is installed at the door, main door. It have a camera, and it have a human detection as well, and this will help you to like control over voice command, you can control the locking system as well in this. So whenever a relative person come, this module will detect this is your relative, it will show the name over here, and with your command it will lock or unlock the door as well. So this is the main functionality of the overall big high level functionality of my project. Now I will show you the demonstration of my project one by one. Okay, so first I will turn on my ESP module. You can see it's have a face expression as well. Later I will update for an animated one as well, but right now it's have a face expression. So I will also switch on, like right now over here I have connected the AC supply, and this is going to connect with the solenoid valve to control the door node. This is to like power on this door node, and this power is given to this AC supply to the smart home node. So let's see what's the functionality of smart home node. So as I mentioned, manually we can also switch on and switch off the light. So when I will this on first. So when I press this, like touch the particular switch, it will light on the lamp. When I also press the switch, it will do that. This is how manually we can touch. Also a socket is also be controlled with it. So if I press the socket, phone will be start to charge. When I press again, it will get disconnected like this. We can also control fan. To show the fan, I have used a halogen lamp over here to show the dim, like controlling the fan speed, the current of the fan. I think it's not. We will come to it later. But right now we'll first see the robot functionality, main basic functionality. So when I give a command, it will also walk and do further things. I'll show you. First we will see some functionality of our robot, and then we will show the functionality of our smart home node. So take it over here because it's going to walk. Hi ESP. Hi ESP. Walk forward. Okay. Okay. Hi ESP. Stop. Okay. Hi ESP. Hi ESP. See you next time. Hi ESP. Let's dance. Okay. It will play sound and dance for kids like this. Hi ESP. Stop. Stop. Okay. Time out. See you next time. Also, it will tell a story to your kids. Hi ESP. Tell a story. Okay. If you are able to hear the voice sharing the story as well and showing the expression of reading story. Hi ESP. Hi ESP. Stop. Okay. So this is one thing. Now we will see these are the main functionality of our robot, and see you next time. And now we will see how it will going to control your smart home nodes. Okay. Hi ESP. Turn on light 1. Turn on light 1. Okay. This would turn on the light 1. And if I manually want to switch off, I can also do that. Like just touching that. I can also give a command to switch off as well. That also will be fine. Turn on the light with that switch. Hi ESP. Turn off light 1. Okay. So it will turn off the light 1. Same for the socket and fan as well. So I will give you another demo of that. Time out. See you next time. Hi ESP. Turn on socket. Turn on socket. Okay. So to show that I have connected a mobile phone which is getting charged with that. So this is how it will control socket. I can also again same switch off with this touch as well. Another fan functionality I will also show. Actually my dimmer, AC dimmer I have used over here, which will dim your AC frequency signal and control the current, mainly the voltage of the circuit, what is the load is connected. Right now I have used a halogen lamp to show the intensity of it. We can also connect to a ceiling fan as well. Hi ESP. Hi ESP. Turn on fan at level 1. Turn on fan at level 1. Okay. It's okay. Right now my AC dimmer is not working. That is I will connect with different particular module. It's a handmade right now, just made with the electronics, so we may get some issues in that. So this is how our smart home node, it will connect, it will turn on, turn off with command and all. So this is how one thing. Now I will give you a gist about health node. We can turn on our health node. Uh, it comprises of several things. I will show later how those things are connected and all. But whenever this health node, you can just wear it like this as well, like a health band. Right? It have this max sensor which will read your health rate and read your oxygen rate and all. But it's important is it detects the fault detection as well. So whenever if someone have wear this and fallen, it will give a SMS over mobile, as well as it will show and siren up in the robot as well. So if I fall, so you can see there is a symbol and siren as well. You can also see a SMS will receive. You got we can see the message. It is from Circuit Digest cloud I have used with 101 template. Yeah, your health band is currently at fault detection, right? So like this you can also have that. I'll remove this and like this. So this communication is going on via ESP-NOW communication protocol. And also meanwhile we can also control we, like to turn off this, we can also say hi ESP stop. Okay. So it will go to the normal state when you pick up your grandfather or someone who have fallen off, right? It will also detect health node, health rate. If the health rate is also going up or something, the same thing will happen, right? The notification and loudness of it. Now we will focus on the door node. As I mentioned, we can also control the door open and closing part. So I will show you that. Hi ESP, unlock the door. Okay. But they cannot unlock the door, but hi ESP, hi ESP, unlock the door. See you next time. Hi ESP, unlock the door. Okay. Unlock the door. So it will do that mainly. So it's right now unlock condition. So if a known person is get detected, for example, alarms for someone, it will show that as well. You can give you that idea. Mainly we can control the majorly door lock and unlock condition mainly with this. I will show its demonstration in detail as well. Right now I need to check functionality of it. The camera mainly trained with very low model TinyML with Edge ML, and I have used Edge Impulse to train the model. So therefore I've used that. Also, so this is how mainly it is. Now we will look into some circuitry, how it is designed up. So for robot, we have used two lithium-ion batteries. One is 650 battery in series, which will have a switch and which will connect with Arduino Nano inside it. And you can also show that how Arduino Nano are connected. So here is the Arduino Nano, and here is the batteries I have connected, and it is controlled it's also this Arduino Nano is supplying power to this ESP module, and also controlling the servo motors for walking and all those things. They both are communicating with one receiver and transmitter via UART. So they are communicating in that way and sending from ESP to Arduino Nano. Need to walk or dance or whatever it is, send the command and do the needful. And also over here in the smart home node, I have used a particular ESP32 development module which is having some 4 touch switches over here, touch switches that I mentioned, and it control the relay based on touch switches and the command it will receive from ESP32 box 3 or ESP-NOW protocol. It also can control this AC dimmer circuit, which will dim or control the AC intensity as well. So like this, and to power up, I have used a particular AC to DC converter module as well. So I can also open and show it to you guys. All the project code and all are available in the GitHub and all. So this is how it look internally. This is the AC dimmer I have made manually. I mean, it's not working right now, but this power module will take AC supply and power it to this ESP32 and also relay module and AC dimmer as well. And socket and all are connected further according to the circuitry. One socket is connected to one relay and one light is connected to one relay. Over here in health node, mainly we are also having this MPU 6050 module, which will detect acceleration. If certain acceleration have there, which means fallen or something happen, it will notify to our circuit. And also if there is a health risk, like I have used max 3010102 module, which will check heart rate as well as the oxygen level. If it goes above the range or something, it will do that. It is powered on with internal battery. I can show that. Here is the antenna, mainly here is the battery and all those things. Here is the switch to control, switch on and off. You can do that. This module uses Circuit Digest Cloud, which is very easy to use and very reliable and very fast to send the messages on phone, and you can also add multiple mobile number as well. And the door node, mainly it comprises of ESP32 CAM module, which is going to triggered with PIR sensor, and also control relay module. Relay module will give you ability to control any type of other control door locking system as well. It is quite able to detect it, but the camera is a bit tilted right now, so I need to just paste it again and then it will work well. And it will also communicate with ESP-NOW, and it will tell if Elon Musk is detected, so it will tell it Elon is detected and all. And via command, as we have seen, we can also control the door lock and unlock conditions as well. So in this we have used edge impulse, that is what we have used to train the model and all. And if more samples if we have, the more accurate the model is. So this is how it mainly used to work, and you can also thanks a lot at the later end. I will also thanks a lot to Circuit Digest to give us an opportunity to make this kind of prototype. Later, if I get an opportunity, I will also scale it up and make it as a product, and also make it a good value out of it, and solve real problem that domain home right now is facing. And thanks to DigiKey as well, who sponsored the circuit board and to give us this kind of opportunity. All the circuits and codes are there in my GitHub repository. I have shared the link in the documentation. Just go and check and make it on your own. Right? Thank you. Thanks to you.